Is our beloved Point Pleasant Park recovering from the devastation of Hurricane Juan? Point Pleasant Park is a municipal park on the southern tip of the Halifax Peninsula in Nova Scotia, Canada. It is part of the Acadian forest dominating the Maritime provinces. In 2003, Hurricane Juan devastated the park, removing over 70% of the even-aged tree canopy. Today, the forest is undergoing secondary succession towards its climax community. A climax community consists of all species which, through succession, have reached an equilibrium or steady state in the ecosystem. Point Pleasant Park's climax community consisted of a tree canopy dominated by red spruce. Previous research has quantified and characterized the change in Point Pleasant Park since Hurricane Juan. In this study, we add to previous research by analyzing the change in selected community metrics and dominant tree species throughout Point Pleasant Park's secondary succession post-Hurricane Juan. Our research can be used to improve forest management practices as we provide an idea of the changing state of the park over the last 18 years, which can inform scientists and policymakers about the extent and direction of which Point Pleasant Park's management could take. Our study also aims to acknowledge the Mi'kmaq Nation and their connection to Point Pleasant Park. The park is situated on the unceded territory of the Mi'kmaq Nation. Throughout the park's history, from untouched land to a British defense site to a municipal park, the Mi'kmaq have known the park as Amnukati, the spiritual place. Thus, as treaty members, we hope this study can be used to restore Point Pleasant Park with intentions of restoring not just the park's ecosystem and the park's use as a municipal space, but to restore the park as a form of respect and acknowledgement of the park's history with the Mi'kmaq Nation.
The first objective of our experiment is to perform a linear regression analysis on the Shannon Diversity Index in order to understand how tree species diversity has changed over time and predict how this metric will act in the future. Our hypothesis is that the Shannon Diversity Index will increase significantly over time.
The second objective of our experiment is to perform a regression analysis on the density of red spruce and a regression analysis on the density of red maple from 2004 to 2022 with data collected at Point Pleasant Park at multiple replicate sites. This is intended to determine how these dominant tree species populations are changing with time since Hurricane Juan. Our hypothesis is that the red spruce density increases with time and that the red maple density also increases with time. We also aim to make a prediction of the fate of these dominant tree species as Point Pleasant Park progresses towards its climax community.
The third objective is to perform a linear regression analysis on the species richness to interpret how it has changed from 2004 to the current community state in 2022. The hypothesis is that the tree species richness will significantly increase over time. The study sites for data collection to determine the ecological changes of the forest community in Point Pleasant Park, Halifax, Nova Scotia after Hurricane Juan were chosen with areas with the highest hurricane impact, with a total of 6 sites that measured 20 by 20 meters. These same sites were consistently utilized for data collection every October from 2004 to 2022, excluding the years 2005, 2007, and 2022. At each site, the data collected includes the density of tree species, which were identified by students using a field guide, and the diameter at breast height, DBH, defined as the diameter of a tree at 4.5 feet above the ground, and this was measured using a diameter measuring tape. Only trees that had a DBH of 2.5 centimeters or larger were included in the DBH analysis. This data was used to calculate the Shannon Index, the dominant species in 2004 and 2022, and the species richness at each site per year. A linear regression analysis was chosen since we're determining the relationship between two variables, the change of growth over time. The linear regression analysis was used for each data set using R-squared values, the F statistic, and p-values, where a strong relationship is determined when R-squared is greater than 0.6, and statistical significance is found by a p-value of less than 0.05.
We used a linear regression analysis of the Shannon Diversity Index to examine how the tree species diversity of Point Pleasant Park has changed from 2004 to 2022 since the disturbance of Hurricane John. There is a weak positive relationship between the tree species diversity and the time that has passed since the disturbance, indicated by the R-squared value of 0.33 and the scattering of the data present on this graph. As the graph shows, tree species diversity has been increasing since the disturbance. We choose to reject our null hypothesis because the p-value is less than 0.05 and conclude that there has been change over time in tree species diversity. So what? Well, Hurricane John took out 70% of the trees in Point Pleasant Park. This caused previously limited resources such as sunlight and space to become more available, which allowed for new tree species to grow, increasing the species diversity. As the community reaches its climax, it is likely that tree species diversity will decrease because one species will become more dominant, and this will cause certain resources to become limited once again.
To understand the change in Point Pleasant Park's structure after the devastation of Hurricane Juan in 2003, we performed a regression analysis on red spruce density and time since Hurricane Juan to determine whether red spruce density increased with time since the hurricane disturbance. As we see here in Figure 3, there is a significant positive relationship, as seen in the low p-value of 0.004 of this statistical analysis, between red spruce density and time since Hurricane Juan, showing that as the years progress from the initial hurricane disturbance, red spruce density tends to increase as well. To understand the change in Point Pleasant Park's forest structure after the devastation of Hurricane Juan in 2003, we performed a regression analysis on red maple density and time since Hurricane Juan to determine whether red maple density increased with time since the hurricane disturbance. In Figure 4, there is a significant positive relationship, as seen in the very low p-value of 7.9 times 10 to the power of -5 between red maple density and time since Hurricane Juan, showing that as the years progress from the initial hurricane disturbance, red maple density tends to increase as well. Previous research has shown red maple to be a pioneer species, which may be attributed to their competitive success due to their two regeneration methods matching certain ecological conditions, where in a case such as a hurricane, red maple of sprout origin will have advantages which allow them to grow faster in such an environment. In our results, we see red maple density increasing more drastically with time than red spruce, as seen in its steeper regression slope, as seen in Figure 4, allowing it to be the dominant tree species of 2022. Red spruce was the dominant species prior to Hurricane Juan in 2003, when Point Pleasant Park was near its climax community. Our results can be explained by the characteristics of these tree species, as we see red maple increasing at a faster rate than red spruce because it does well in early secondary successional communities, while red spruce is a slow-growing species which will take longer to be densely established. One aspect of our study was to predict the fate of these dominant tree species as Point Pleasant Park's community comes closer to its climax community. With our results and previous research on these trees' characteristics, we follow the suggestion of Foster in 1998, and that red maple will experience thinning, allowing the shade-tolerant red spruce to become the dominant species.
To interpret how the community metrics of Point Pleasant Park have changed post-Hurricane Juan, we completed a linear regression analysis to determine how species richness has changed from 2004 to 2022. It was found to be a significant and strong positive relationship between the change of species over time, as species richness has almost grown 4 times the amount in 2022 compared to 2004 post-hurricane. This analysis showed that 66% of variation in the change of species richness was influenced by a change in time. This data is also significant as our p-value is less than 0.05, and therefore we were able to reject our null hypothesis. Sharma et al. And Turchin also found the same positive relationship between species richness changing over time during secondary succession. However, this dramatic increase is explained by an abundance of resources as Point Pleasant Park continues to recover from Hurricane Juan. According to Hugh et al., as resources become more limiting, the trend between species richness and time will begin to decrease and it will reach a plateau. With this as support, it is predicted that as the forest continues to move towards its climax community, the species richness will eventually reach a plateau as the community stabilizes, as resources become more limiting due to dominant species overtaking space and nutrients.
Ultimately, for all our regression analyses, we chose to reject our null hypotheses and conclude that there was change over time in all the metrics we studied. Species diversity has been increasing since the hurricane, but will begin decreasing in the future. The density of both red maple and red spruce have been increasing, but in the future, red spruce will likely become the dominant species and red maple will stop increasing. Species richness has been increasing over time, but in the future will likely reach a plateau and stop increasing. So what happens next? Well, the results we have found show that Point Pleasant Park is following the trends of secondary succession and recovering well. The question of our predictions can only be answered through more data collection and analyses every year. Climate change is warming our planet, including the ocean. Hurricanes are fueled by warmer waters and moist air. The severity of hurricanes hitting Halifax is likely going to increase as the planet warms, which begs the question, how much disturbance can Point Pleasant Park handle, and how will our studied metrics be affected?
We would like to thank the Bio 2060 Dalhousie University Ecology class students from 2004 to 2022 for collecting the tree density and size data per species in each replicate site in Point Pleasant Park. We would also like to thank Dr. Allison Schmidt for analyzing the collected data. Finally, we would like to acknowledge the unceded territory of the Mi'kmaq Nation, a part of which we collected our data from.
To answer the question about what living conditions are present in Point Pleasant Park that strongly favor the growth of a dominant species, I wanted to compare both the pre-hurricane and post-hurricane dominant species to really highlight the changes that an ecosystem goes through during secondary succession. Pre-Hurricane Juan, Point Pleasant Park was in a mature age class, and the hurricane had likely affected older, taller trees much more significantly than the younger trees, as they had more cover from strong winds. Pre-hurricane, the dominant species in Point Pleasant Park was the red spruce. Red spruce is a climax species, which makes it an effective competitor when resources such as nutrients, space, and with this specific species, sunlight, are limited. Prior to the hurricane, the canopy-like conditions in Point Pleasant Park favored the red spruce because it could outcompete the other species since it had shade tolerance. Red maple, on the other hand, is a pioneer species, which makes it a more effective colonizer, and it favors open spaces as it's not as shade tolerant. Post-hurricane, the living conditions in Point Pleasant Park were much more open, and this, along with its quicker life cycle, allowed for the red maple to be the current dominant species in Point Pleasant Park.
This question is concerned with hurricane frequency, which will have no increased effect on red spruce growth as there is no evidence that hurricane frequency is increasing with climate change, but is in fact potentially decreasing while increasing in severity. Climate models predict that there will be less frequent North Atlantic hurricanes with a greater potential to reach a Category 4 or 5 level of severity, which can have winds ranging from speeds of 209 to 253 kilometers per hour and above. To exemplify the severity difference, Hurricane Juan was a Category 2 hurricane. Therefore, hurricane frequency will not impede slow-growing red spruce from establishing. Red spruce are considered established when their seedlings reach 15 centimeters in height. Hurricane severity, however, likely does impede on this establishment. Red spruce establishment and abundance will be negatively impacted by increased hurricane severity, as Category 4 and 5 hurricanes have an even greater ability to uproot trees than was seen by Hurricane Juan. Red spruce will be specifically impacted by this as they are a shallow root system species, making them more susceptible to being knocked over by wind throw. This will decrease the amount of red spruce trees which are able to reach seed-bearing age, which could lead to species endangerment. A less likely factor, which could become more relevant to this question in the future, is that red spruce produces seeds after 30 to 40 years of growth, with abundant seed crops every 3 to 8 years. Evidence by Burley and al. showed that the accumulation of these viable seeds in the soil was not significantly impacted by Hurricane Juan in Point Pleasant Park, but further research will need to be conducted to reassess hurricane impact on the seed bank with higher category hurricanes.
Removing the colonizing species would make limited resources more available to all plants, including the previously dominant tree species, red spruce. However, colonizing species have high population growth rates, and red spruce is a slow-growing species. In order for this method to be effective, colonizing species would have to be removed periodically. Burley et al. Suggests that the rate of recovery could be increased by planting supplemental larger trees as well. In theory, these methods would increase the succession rate towards a climbers community at Point Pleasant Park. A climbers community is characterized by stability, an increased likelihood of either withstanding or recovering from disturbances. As hurricane frequencies increase around Halifax, this characteristic will be necessary to preserve Point Pleasant Park. So yes, I believe interfering would be beneficial, although further research should be put towards the pros and cons of this suggestion.